Hello everyone, I am Bhoomi Shivhare and this talk is around liquid galaxy streamings, specifically keeping GSoC 2026 in mind. So, liquid galaxy is extremely powerful, but if you've ever worked with it, you already know this. Like a lot of power comes from the KML, and writing KML can get slow and honestly repetitive. I kept asking myself, why are we still doing so much of this manually? Why does building tours or camera paths still take so much time? That question led me here. This presentation is about speeding up KML development using a Gemini or AI assisted workflow, not to automate creativity, but to remove the friction. So, I'll walk you through why KML matters or why KML is so important in the liquid galaxy environment and how AI can actually help developers work faster without losing control. So let's start with why KML is the core of everything. Okay, so before we talk about speeding things up, we need to understand why KML even matters this much in Liquid Galaxy. See, KML is not just about showing places on a globe. It literally controls how Liquid Galaxy behaves, where the camera moves, how tour flows, like where place marks appear, disappear, zoom in, zoom out, all of that. So when you see an immersive Liquid Galaxy demo, the smooth camera motion, the storytelling, the way it feels almost cinematic, that experience is coming from KML. So, it's also the backbone of almost everything we build on Liquid Galaxy: demos, permanent installations, live presentations. Without KML, Liquid Galaxy is just screens. So, when we say KML defines the experience, we really mean it. It's not just visuals, it's the entire narrative. Sorry. Now, here's where the problem starts: the bottleneck. Writing KML manually is unforgiving. One missing bracket, one small syntax issue, and the entire visualization just breaks. So there's no partial failure. It's either working or it's not. On top of that, anything involving smooth camera movement or 3D path means doing math manually. So interpolation, coordinates, timings, and that gets messy very fast. And the workflow itself is slow. So you write the code, deploy it, something crashes, you debug, you redeploy, and the cycle repeat again and again. So what ends up happening is that we spend most of our time fixing syntax and very little time focusing on the actual story we're trying to tell. That's the bottleneck this work is trying to address. So this slide shows the idea that really changed how I approached KML generation. If you look at the diagram here, you notice three things: role, context, and constraint. So that is not accidental. First, we clearly tell the AI what role it should play. For example, act like a Liquid Galaxy KML expert. That immediately sets the tone of the output. Then comes the context. Here I explicitly mentioned things like Google Earth, tour extensions. So the model knows exactly which part of KML we are talking about. And finally, the constraints: asking for valid XML, properly closed tags, no shortcuts. The key idea which you can see written at the bottom of the image is simple. The quality of KML depends on how precise the prompt is. When we structure the request properly, the output becomes predictable and usable. That's what it completely states. Okay, so this slide shows what we actually get at the end of the process. So if you look at the code snippet here, you'll notice it's not just a random XML. It follows a very clean hierarchy where you can clearly see the GX tour, the GX playlist, and how everything is structured correctly. One important thing happening here is that the math is no longer manual. So we have already broken the barrier. The AI handles coordinate interpolation from smooth camera movement, which removes a huge source of human error. And because the syntax is already valid, tags are closed, nesting is correct, like this KML is basically ready to deploy directly to Liquid Galaxy node. The big shift here is that it's written on the slide as well, that we move from debugging syntax to simply reviewing logic. Now we just have to review what the AI is giving to us, and that saves enormous amount of time. Okay, now this is where the workflow really changes. Earlier, even a small adjustment meant tweaking numbers, saving, reloading, waiting for something to break, and then repeating the whole loop. A single camera could easily take like 15 minutes. Now, instead of rewriting code, the interaction becomes conversational. You can describe the change, make it slower, add a spiral, smooth the ascent, and the system responds immediately. The complexity hasn't disappeared. The math is still happening in the background, but it's no longer blocking creativity. So instead of iterating on syntax, we iterate on the intent. That's very important, and that's what enables rapid prototyping. Okay, so why the human is still the architect? This approach still has limits, and that's important to acknowledge. Gemini can sometimes invent things that look correct but aren't, like KML tags that don't actually exist. In longer session, it can also drift and forget early constraints, and it doesn't have real awareness. So it won't automatically know if a camera path clips through terrain or structures. So that's why the human role doesn't disappear here. The AI accelerates the work, but decisions, validation, and responsibilities stays with us. So the rule is simple: trust the output, but always verify it. Like, verification is the key here. Standardizing the output. Okay, so to make this usable at scale, consistency becomes critical. So instead of starting fresh every time, we begin each session with the predefined system prompt, something that sets expectation before any generation happens. So the persona is fixed. The AI behaves like a Liquid Galaxy engine, not a creative assistant. Like, certain rules are non-negotiable, like valid XML, strict structure, no absolute altitude. So by defining these constraints upfront, the output becomes even more predictable. So reliability comes from definition, right? Not just correction. We have to define it properly. So that's when we can get our results like the way we want them. Okay, solving the jagged flight problem. So one of the most visible issues in the manually authored tools is how the mechanical movement feels. Like, when motion is defined using only a few points, transition becomes sharp and unnatural. Like, fixing that manually means calculating intermediate points and handling interpolation yourself. So here the responsibility shifts. You describe the kind of motion you want, and the intermediate coordinates are generated automatically using smooth curves. Like, the end result feels very cinematic and more like controlled flight than jumping just between the positions, like as you can see in this image. Okay, beyond movement generating screen overlays. So far I've mostly talked about movement, but a good tour isn't just about flying the camera. A real Liquid Galaxy experience also needs context. Titles, logos, labels, bits of data, things that help the audience understand what they're looking at. So the problem is that placing screen overlays manually is very tedious. So you end up guessing X and Y pixel values, tweaking them again and again until something finally looks right. So here that friction disappears. You describe what you want, for example, a logo in the top left corner at a specific size, and this correct screen overlay structure is generated instantly. So the result is that UI stops being an afterthought. It becomes a part of the storytelling without slowing the developer down. Okay, so dynamic data injecting real time information. So this is where Liquid Galaxy stops feeling like a pre-recorded demo and starts behaving like a live system. Instead of showing static labels, we can inject real-time data, like things like locations, live locations, sensors, values, or weather updates. So the bridge here is very simple. A lightweight Python script fetches data from an API, formats it, and updates the KML through a network link. And Gemini helps generate and adapt the glue code quickly, so we're not spending time writing things manually. The important shift is very conceptual, like the KML becomes the canvas and Python becomes the painter. So Liquid Galaxy turns it into a live dashboard, not just a simple visualization. So as projects grow, like a single giant KML file becomes a real problem. When everything like tours, place mark, overlays lives in one file, it becomes unreadable, fragile, and very hard to debug. The solution is to treat KML like modern software. We split the project into smaller focused files and connect them using network links. So Gemini helps automate that structure, generating that linking logic so the system loads everything cleanly and clearly at the startup point. The payoff is huge. Like if one part breaks, the rest of the system still works. The project becomes scalable and maintainable, and that's what we want, I guess. So once the KML is structured properly, collaboration becomes much easier. KML itself is just text, which means it works very well with version control. The trick is keeping assets separate and the structure clean. With that setup, like teams can review changes, compare differences, and roll back mistakes just like any other software project. So Gemini can even help analyze those differences. For example, understanding why a tour break after a merge. So at that point, Liquid Galaxy content stops being something you email back and forth, and it becomes a proper software repository. One very practical constraint with Liquid Galaxy is access. We can't always use the full rig to test very small change. It is shared, it's expensive, and it's not realistic to block it for debugging. So instead, we validate most of the logic locally. So we use global Google Earth Pro on a laptop as a kind of simulated node. Gemini helps generate a simplified version of the tour. Same timing, same structure, just scaled down to a single screen. So once the flow feels right, we deploy the resolution version to the cluster. So it's a simple idea, but it can change the workflow completely, like develop locally and deploy globally. Okay, so performance is another piece where small decisions matter a lot. So if we load everything at once, thousands of bridges, buildings, detailed models, like the frame rates drop immediately, especially on the master node. So the solution is level of detail. Heavy assets stay hidden until the camera is close enough for them to matter. So the tricky part is tuning it correctly, knowing when something should appear so it feels seamless, not jarring. So Gemini helps with that logic, wrapping models like in regions, setting activation thresholds so performance stays smooth without manual trial and error. So the goal is simple: keep the experience fluid even as screens get complex. Okay, the case study. So this slide is about speed, not performance speed, but the response speed. Imagine a major event happens, an earthquake, a solar eclipse, something newsworthy. You need a visualization immediately. So traditionally preparing that would take days, collecting coordinates, drawing shapes, fine-tuning the visuals. By the time it's ready, the moment have passed. So with this workflow, raw data can be fed directly into Gemini with a simple instruction: plot these points, style them this way. So the result is broadcast ready. Liquid Galaxy tour in hours, not days. So while the event is still relevant. Democratizing the platform. This shift changes who can actually build on Liquid Galaxy. Earlier, you needed deep KML knowledge or low level system understanding just to make something move. Now, someone can describe what they want: a historical tour, a geographic story, and get a working prototype very quickly. That doesn't reduce the role of engineers, it changes it. So instead of typing brackets all day, we focus on building systems and tools that empower others: artists, educators, researchers, and so many more. So the limitations just stops being syntax, it really becomes an imagination. Okay, so up to now, everything I've shown still assumes a human asking for something. So the next shift is when that changes, when the system starts reacting on its own. Like, instead of prompting manually, an agent can watch the state of Liquid Galaxy. If the focus moves to a place like New York, it can automatically pull relevant data and generate a tour around it. So technically this means connecting context, location, voice input, system state to KML generation, and the long-term idea is a Liquid Galaxy that doesn't just wait for instructions but actively arrives the experience, so that a system that can narrate its own journey. Moving to the next. Okay, the formula for success. So after experimenting with all of this, one thing became very clear: reliable output doesn't come from clever prompts, it comes from structure. You always start by defining the role clearly, then you lock down the rules, especially what not to do. So after that, you give a very concrete task with numbers and intent. And finally, you control the output format so the result is usable immediately. And when you follow this pattern consistently, KML generation stops feeling unpredictable and the code becomes, just the medium. The real mission is the story you are trying to tell. Okay, from coding to directing. This workflow fundamentally changes how we think about building Liquid Galaxy content. We're no longer just writing XML taglines by line. We are directing an intelligent system that gives us speed, faster development cycles, complex paths, dynamic data, but it only works if it's balanced with engineering discipline. System prompts, modular design, version control, those things keep the system stable, while AI keeps it fast. So, together, they let us build the next generation of immersive experiences, better, richer, and much faster than before. Okay, so now to wrap this up, this work is really about removing friction, making it easier to experiment, to iterate, and to tell better stories with Liquid Galaxy. And AI doesn't replace the engineer here, it amplifies what the engineer can do. And when we design the workflow carefully, we don't just move faster, we build smarter. And thank you. Happy to answer all your questions.